Hello everyone. Today we will be discussing chef and cakes problem, that is the first problem of November 2015 long challenge. In this problem we were given n and m, that is n is the total number of robots and m is the first m robots which are moved to the back. So here we were supposed to calculate whether we can successfully give package to all the robots or no. If no, then we have to print the number of robots which will get the packet. So this problem was little bit tricky, and many participants couldn't get total 100 points. So in this problem, if we follow the regular uh, method, that is actually going through the indexes, then we will get only 25 points. To get 75 points, we have to use some other logic that is meant for this problem. So such kind of problems are need to be solved by taking a pen and paper and just plotting it down. And here is what you should do. Here we are giving n, that is from 1 to 11, we are considering 1 to 11, and m is from 0 to 10. Now for n equal to 1, m is always less than n, right? So we can have only m as 0 for n equal to 1. So we have this. Now for n equal to 2, we can have m equal to 0 or m equal to 1, right? Now we are supposed to calculate these values, and before that some trivial cases would be discussed. So for one of them is m equal to 0. Let's take m equal to 0 for n equal to 2. For n equal to 2, before the array was like this, 1 2, then after taking the first m numbers and adding them back to the back, we'll get again the same values, right? Note that whenever we get the values as same, the answer would be no 1. Why? After this we will traverse through the indexes. So we'll go through the first index. Now as they have told us that we have to traverse by taking the value in that index and going to that index. So we are going to this index first and taking the value is 1. So we are going to the first index again. So we are going back to this index only. So the loop has been stopped. We can't go to this point. So answer would be no 1 always. But there is an exceptional case for n equal to 1. For n equal to 1, as the total number of robots are 1 itself. So and here we have seen that first robot is getting completed, getting the packets. So for n equal to 1, that robot will get the packet itself. So answer would be yes, as the total all the robots are getting packet. So after calculating these values, let's consider m equal to 1. For m equal to 1 and m equal to n minus 1, the answer for m equal to 1 is this one, and m equal to n minus 1 is this diagonal elements, this one, sorry, this will be yes always. Why? I request you all to do it yourself by just trying them on paper. Now for m equal to 2, we calculated the values, and for rest of them also. Now after calculating the values, we notice that, let's say, consider n equal to 8. So for n equal to 8, we know this values, right? We know this values also. We have to calculate this values, right? This one, this is also m equal to n minus 1, that travel case. So we have this values which are needed to be calculated. Now if we look carefully, then for m equal to 2, answer is no, and the value, total number of robots getting the package is 8 by 2, right? 4. For m equal to 3, answer is yes, and for m equal to 4, answer is no, and number of packets is 2. So we can see that whenever n modulo m is not equal to 0, then we are just taking it as yes. Here also 8 modulo 3 is not equal to 0, so we are taking yes. 8 modulo 5 is not equal to 0, so we are taking it as yes, and 7 also, right? Now this numbers are remaining, that is, let's say m equal to 2, this one. So we can conclude that for whenever n modulo m equal to 0, then answer would be no, right? But the value in the answer would be here 8, n is 8 and m is 2, so 8 div 2, that is 4. Similarly here 8 and here 4, so answer is 8 div 4, that is 2. Similar, now we can calculate up to n by 2, that is m equal to n by 2. n here is 8 and m here is 4, so we have successfully calculated up to n by 2. But for this part, we know this one, we know this one, we have to calculate this. Now 8 mod 6 is not equal to 0, right? Still answer is no 4. Why? Because we can see a symmetrical pattern, right? So many of us try to use that symmetrical pattern to calculate up to this part, and then just copying this, that is, this value is same as this, right? This value is same as this value, and this value is same as this value, so there is a symmetry. But here was a catch. After submitting a lot of time and getting wrong answer, I noticed that this was the reason, and we should try something new. So instead of following the symmetry, I just use GCD. So say we want to calculate n equal to 8 and m equal to 2, so we calculate the GCD of these two numbers, that is 2, right? And then div n div 2, that is 4. For m equal to 6, GCD of 6 and 8 is 2, right? So 8 div 2, that is 4. Let's understand the code. We are taking input n and m. Now these are the travel cases. When m equal to 0, that is this part, but n not equal to 1, that is excluding this blue part, that is this part, the answer would be always yes, always no and 1. And for these cases where n equal to 1, m equal to n minus 1, or m equal to 1, we are printing yes. Those were travel cases, that is this, and diagonal elements, that is this part. else we are calculating GCD, and if GCD is 1, then we are printing yes, say n equal to 8 and m equal to 3. So GCD of them is 1, so we are just printing 1. Similarly here 8 and 5, GCD is 1. Else the value obtained from GCD is divided by n is divided by that value, and that value is printed along with no.